Good morning, students. Let's continue with another topic of fifth unit, that is object-oriented testing, or simply call it as testing object-oriented software. So, what do you mean by this object-oriented technology? It was established with a number of object programming languages. So we have done now, earlier it was like structured programming languages came into existence. Then we have different types of testings like unit testing, integration, validation, functional testing and all. With the incoming of these object oriented languages, then we have specific technology that is required for testing here, right? So the paradigm, this OO paradigm, that is object oriented paradigm, is embedded in the complete software engineering approach because we develop the software using object oriented approaches also. So they work both together. Now, what is most challenging about this object oriented software? Most of the testing concepts lose their meaning in object oriented technology. For example, a unit in object oriented technology is not a module but a class, right? So in unit testing we used to say we have to check each unit, that is each module in isolation, but in object oriented approach there is no concept of module. There we have a class. So those methods of testing which were applicable there are not or cannot be applied here. Then a class cannot be tested with input-output behavior as in unit testing of the module. Like in the unit testing module, we have created an environment. We used driver and the stub modules to, you can say, simulate the environment, get the inputs and outputs, and we carry forward the testing. But here, this is not possible. So thus both the testing strategies and techniques change in case of object-oriented software. So traditional methods cannot be used. You require some additional methods of testing here. So it becomes challenging. Now, what is a major difference? The first and the foremost point is complexity. The major reason for adopting object-oriented technology and discarding the structured approach is the complexity of the software. Structured approach is unable to reduce the complexity as the software size increases, thereby increasing the schedule and the cost of the software. So, using structured approach, the complexity increases with the size, right? Thereby increasing the schedule and the cost. But if we use object-oriented technology, is able to tackle the complexity and model the software in a natural way, right? So no additional or extra cost or schedule is required for that. In the structured approach, the emphasis is on action, not on data. That means function. We are concentrated more on the action of the function part. While in case of object oriented, we are more concentrated on the data. And at the same time, the data is hidden here. It cannot be accessed by everyone. So it is more secure. While in the case of structured approach, we have global data which can be accessed by anyone. So it can be corrected at any moment of time. So object-oriented technology is more secure because data is hidden here. Then functions in a structured approach are not able to model the real world entities, right? While in object oriented, we know that we can model the real world entities and solve the problem in a more obvious and natural way. So these are the basic, you can say, advantage of object oriented technology over structured approach. Now, few concepts relevant to your object oriented technology. Everyone knows what is an object. An object is an abstract entity which represents the real world, right? Class, all objects with the same structure and behavior are put under one class. So class act as a blueprint which defines the data and behavior common to all the objects of a certain type. While encapsulation, a class contains data as well as operations that operate on data. In this way, data and operations are said to be encapsulated in a single entity, right? Abstraction. Shaw was the scientist, right? Defines abstraction as a simplified description or a specification of a system that emphasizes some of the system's detail or property while suppressing the other. So abstraction is simply arranging the system into abstract levels, right? And only those level is available to the users while the inner level details or other layers are being hidden, right? So this is how we only show the relevant details while we hide the irrelevant details with the help of this abstraction. Inheritance is a feature. It is a strong feature of OOT. It provides the ability to derive new class from the existing class. The derived class inherits all the data and the behavior of the original base class, right? So it is also a good concept. Polymorphism. This feature is required to extend an existing object-oriented system. Polymorphism means having many forms and implementation of a particular functionality. So we can have multiple forms. So these are the few terms that are used in object-oriented paradigm, right? Now, talking about object-oriented modeling and UML. So what is modeling? Modeling language. Model is a framework, right? Modeling languages, we prepare different models to represent your system with different viewpoints. Now, what is used for that? In order to make a model, we use a unified modeling language, right? So it is UML is nothing. It is a graphical tool which you use to visualize a system with different viewpoints. So here we'll be discussing few of the diagrams and their viewpoints. The first one is a user view. This view is from the user's viewpoint, which represents the goal and objective of the system as perceived by the user, right? So we understand the system as far as user is concerned, and the model that is prepared here is known as a use case diagram. Structural view. Structure view, as the name suggests, represents the structure or the organization of the system, and the class diagram and the object diagrams are used to represent the structural view. Then we have is a behavioral view. As the name suggests, this represents the behavior of the system at runtime, or the dynamic behavior is represented. And the diagram or the tools used are collaboration diagram, sequence diagram, state chart or state transition diagram, and activity diagram. Implementation view. This implementation view represents the distribution of logical elements of the system, which helps in execution. And component diagram is a tool which is used to represent this implementation view. Last is your environmental view. This represents the distribution of physical elements of the system, how they interact with your system. It depicts the nodes which are part of the physical hardware for deployment of the system. And the system used or the tool used is user's deployment diagram. So ultimately you have seen we have 5 views: user's view, structural view, behavioral view, implementation view, and environmental view. And each of the view use different modeling diagrams. Now these are the diagrams which we have done in software engineering earlier. So I'm not going to take much of detail for these use case diagrams. Like, you know what is a use case diagram, where we make the use cases, we make an actor, and how these actors are involved in these use cases is represented here. A class diagram represents the classes and the relationship between the classes, right? Similarly, we have sequence diagram, where the sequence of activities are represented between the components of the class or between the external entity and the components of the class. Activity diagrams represents the sequence of activities. So likewise, we have done almost all the diagrams. Few are new here, like collaboration diagram, component, and deployment diagram. Rest we have done everything. Like state transition diagram, we have done with the help of the example of an microwave oven earlier. So brief is discussed about them. Now we'll see how these diagrams are going to assist in object-oriented testing. So if I say the first diagram is your use case diagram. So use case diagram is used in functional testing or acceptance testing, right? So it is going to help us in testing of system level functional requirement and acceptance testing. Class diagram is used for class testing, modular unit, right, and integration testing. So this is one of the things which is very important in object oriented, key which all diagrams are used for which type of testing. So you have to do it properly. Then sequence diagram and collaboration diagram, it helps in integration testing, testing of control and interaction between objects, testing of communication protocols between distributed objects also. Then activity diagram, testing of workflow and synchronization within the system, right? That is workflow, the continuity of the work, sequence of activity needs to be tested here, and white box testing of control flow. We know what is a control flow diagram. So again there is a sequence involved, a sequence of activities involved. That is why this activity diagram can assist in white box testing also. Then state diagrams or the state chart diagrams, it is helpful in state-based testing. This we have done in our second unit. Package diagram and component diagram used for integration testing, while deployment diagrams are used for system testing. So kindly go through it. Not much is required, but at least this table should be known to you properly. So that's all for your 5th unit. We'll continue with some more topics also later on if the time permits. Thank you for today.